Whoops. Yes, right. Okay, let's go ahead and get started. Today we're actually going to cover linked lists. But before I do that, I have learned while teaching this course that the earlier I start going over the STL, the better everyone's lives are. So I'm going to start doing that now. Welcome. So I'm going to go over what the STL is. Standard template library, basically C++'s built-in utilities for general use, kind of like Java's standard library. And then we're going to go over actually only two things from the STL, the string library and the vector library. And you'll find out the string, hey, that should make some sense from Java. And then vector is literally the array class we just built. Okay. So STL stands for Standard Template Library. Standard, basically, it's the accepted extension to C++. Template, meaning it uses templates for polymorphism. It's how it makes so you can utilize it for basically any type of data you have. And it's a library, which means you may use it or you may not use it. In other words, you're not forced to use it, but it's always available because it's standard and it's a library. All right. So it provides helpful function beyond the C++ essentials. The four things it gives you: one is string for manipulating characters. The second one's containers, which provides data structures. So it's going to provide pretty much every data structure we're going to go over in this class, but it provides it as a library. You may ask then, why are we coding them ourselves? Well, it's so you can prove to me you know how the data structure works, and that way you'll use them more effectively. It does provide algorithms for optimized implementation of common functions. For example, if you need to sort, it has a quick sort function for you that you can just call, and it'll quick sort your container, which may be a vector or something else. Lastly, it has something called iterators. Did y'all do iterators in Java? All right. So, generic method to traverse containers. So it has its own list of iterators inside of it. All right. Why use it? Do you really believe? Yeah. Every once in a while I get a programmer that thinks we should not use any type of library, but really you think your code's going to be better than a group of professionals' code? Anyone believe that? Maybe? Nice. That's confidence. Confidence is good. Confidence is good. Well, you got to be careful when it turns into arrogance, right? You pass. Go into the dark side.
Until I realized that I forgot to put a semicolon somewhere and I can't find it.
No. Yeah. See, they've already fixed that for you, right? So people have worked out, I'll say, almost all the bugs. There is pretty much no bug-free code out in the world, but they have worked out the vast majority of them. They have optimized their implementation, so it's going to have far better performance than what you're going to do. I pretty much guarantee it. And people have accepted the interface, which facilitates reading. In other words, when they see vector, they know exactly what a vector does. If you create, my array vector class, they don't know what that does. So a third reason to actually use this is because it is standard and therefore easier to read. When another programmer comes in, it's easier to read your code. All right. Okay, STL is huge. Did y'all notice the Java library was huge? Yeah, it just kept going and going and going and going. STL is fairly large, although definitely not as big as Java's standard library. But if you have a question about the STL, before you ask me, please Google it. Literally type your question into Google. Google used to have this I'm feeling lucky button. I loved it because it just took you to the first web page. Yeah, just click that, the first one, Stack Overflow, C++.com, whatever. It's going to tell you. I'm going to only showcase a few, but I do expect that you are going to have to research more functionality on your own than what I'm going to provide. So if you come to me and say that, hey, you didn't show how this worked, I'm like, yes, I know. Figure it out. That's part of this class, figuring it out. All right, any questions so far? All right, let's go over strings. I'm going to try and make this pretty simplistic. And see, wait, did y'all do string or char star when y'all did strings? Ooh. Oh, y'all use string. Oh, okay. All right, well in C it's really a character array. Hence, string, array of characters.
Yes.
All right. But apparently you all use the string class. Okay. This is how you would actually...
Is that good or bad?
Neither. No,
Oh,
neutral.
Whatever works.
I just assume that y'all, if you're programming in C, this is how you did strings. This is really the only way you can do strings. You know, a character pointer str, it's pointing to a character, and then you send it to an array of characters. And then you can use printf to print it out. All right, printf function like cout. %s means put the first parameter here as a string and print it right here. So that's why str is a character array, so it's going to print it right there. You did %d, that would be for integer. Don't know why. %f is float, but % whatever means stick that value right here. So for up here with printf %s, go ahead and print str. All right. But you probably did it some way like this, except for maybe you had a using namespace up there. So you did something like this where you set a string and then you couted it? No, okay. All right. Well, the rest of these slides are going to be real fast. You can set it equal to a text. You can call the constructor. You can call different constructors, and then you can set one string equal to another. All right. Length of a string is returned by its size operation. Notice that a C string is an array of characters and therefore does not have a .size function. But the C++ string class from STL has a .size function. All right, real quickly, what does this print out?
The size of something is 9 here.
Right. So we got 9 characters. And C++, it is going to say 9 characters. In C, it would be 10. Because in C, the way an array works, a string works, is there's a null terminating character, 0 at the end, and that's when it knows that the string ends. So there's always one extra character than there actually exists.
In C, right?
That's in C
Okay.
with strlen, but we're using C++. I thought you were taught the C way. But that's perfectly fine. You're taught the C++ way. Just need to know what you're using, really. It's not like one's bad or good. Just need to know what you're doing. So here, .size is 9 because there are 9 characters in the string class, or object, sorry. All right, concatenation is done with plus. I assume y'all did that as well. Great, you didn't have to do strcat. You can set it equal. So str2 after this code would be the wall. All right, double equals is legal in C++. So yeah, that's perfectly fine, double equals between 2 strings. Keep in mind that in Java, this would do something different, but in C++, it's actually going to do what you want it to. As long as there's no point, as long as these aren't pointers. If these were pointers, then double equal would be comparing the memory address locations. But since here these 2 classes are on the stack, you're actually comparing the 2 classes explicitly. All right. And any questions on string? Sounds like we already did it, which is great. Good morning. All right, vector. Vector is part of the container section of STL. It provides an alternative to the built-in array. A vector is able to grow itself. It will resize itself as you add and remove elements. Use it instead of the built-in array moving forward. Or at least I highly recommend you do, because you'll have fewer issues. So, what's the syntax? You make a vector of something. For example, vector, and then you do a little less than, int, greater than, you'll have a vector of arrays. For now, you can just replace the word vector with array. So vector of it, you now have an array of integers, of string, vector strings. Notice you can put pointers in there too. It's a vector of pointers to integers. And then shape, you can have your own shape class, so this will be a vector or an array of shape objects. Similarly to your last lab, it's just now it's built into the language. Okay. By the way, I'm going over vector so y'all can use it, but we're going to move on to something else afterwards. just so you know this is available. All right, vector, you can use it two ways: the array style way, which is the way you're used to using an array, or you can do the STL way, which is going to provide a couple more capabilities that you may prefer. First off, STL's vectors mimics standard array usage. So if you create a vector of integers and gave it 10, meaning that this vector or array has 10 elements in it, you could then use each element of the vector just like you would with a regular array. So after you declare the vector, it behaves just like an array.
So really, the only thing we're using to use vectors is ease of use?
Ease of use, yes. And as you'll see soon, it's going to make your life a lot easier. The STL way is you use something called pushback. Now let's look at this code. You make a, actually I didn't declare the vector here. Oh yeah, I did. SVec, string vector. I get a word in and then I push it back. What's different about this code than the previous? Or maybe I should ask it differently. Have I declared the size of vector? No, I have not. What does that imply that vector is doing for you?
Changing size.
Yeah, changing size or, yeah. So vector, if you call dot pushback, notice you have to call dot pushback. If you do subscript, it's not going to do it. But you call dot pushback, it's going to automatically resize itself for you. Yes.
Okay.
But remember, you can use an array to implement a stack or a queue.
Well, yeah. Cool.
The stack and queue is an abstract data type. This is an actual data type that you use in your code. Yes.
So it's gonna resize itself to Word?
It resizes the vector. So if it was currently 0, you added something, it would grow itself so that you could put it in there.
So in this one, it grew itself to 4?
Well, it depends on how many words are coming in. Because it's while seeing word, while you keep getting words from CN and you don't get the end of file descriptor, it'll just keep putting words into this vector. So if you had 100 words, the vector would have 100 elements. If you only put in 10, it would only have 10. So is that easier or harder than an array? Easier, okay. Notice that it has to resize itself, so pushback may be a slow operation. Yes?
So if you have a vector of 10 elements and you just, how would you like to just remove one of them?
How would you remove one of them? That is a great question.
And so that adds it, pushback adds an element.
Why do you need that? Ooh, CS monitor, that's cool. How do you remove from a vector? C++. All right, good old Stack Overflow's got our back. How do you erase? Okay. So you use dot erase, vector begin +1. So if you want to remove the first element, it would be that. Yeah, vector, yeah. Okay, so you have to use this erase function. All right, let's go look that one up. STL vector erase. Oh, C++ erase. C++.com.
That's a good one.
Yep,
That's weird.
this site is good, but they are slow. So erase is a function of STL vector. Removes from the vector either a single element position, so that'd be the first function, or a range of elements from first to last. So you have to give it its position. Position's an iterator to be removed from the vector. All right, how do you get the first position? Well, that's what dot begin is. Dot begin is the first position. So if you want to remove the second element, you would add 1 from vec dot begin. And that would remove the second element.
So doing pushback extends the vector by what you add, and it just adds on directly to the end,
Yeah.
and then that's the way you cut that.
Insertion, yeah, you can push back, inserts an element with value at the end. There's an example, resizes itself. What do you use to find the size of a vector? A function, good. How would you find out what that function is? Google it, there you go, thank you. Trying to make sure this is clear. Don't ask me how to use a vector. Don't ask. Just use Google.
Comes to office.
What?
It comes to office. Hey, what's that vector?
Don't ask me. Yeah, yeah. All right, we'll go down here. Vector. Hey, look, a size. Return the size. Click on size and it would give it to you. Cool. How about pushing to the front of a vector? Push front. That's a good guess. Again, why don't we just ask Google? Guys, I'm just tired of these questions. Like, just go to Google. It's going to tell you. And I don't think it's actually push front. It's insert. So insert sounds like something that's useful. Why? It really wants to know my. So position, you can do dot begin, and then the value would insert it at the beginning. So dot insert, you can put it in any position.
Because there's no point in doing push front if you can just do insert at the first position.
Okay, great. All right, a couple other things I want to at least alert you to, besides this keyring that really wants me to put in my password. There's a return size and return capacity. Can anyone take a guess on what the difference is there?
Return size would do the how many integers or whatever is in your array.
How many elements are in your array, correct? And what's capacity?
I guess capacity could be like it goes on the heap to see if everything was used in the array. Like how many integers are actually
Ooh, I think you're close.
Is capacity the max elements it will be able to hold because of its memory location?
Yes. So capacity is the current number of memory elements allocated to the vector. Size is how many you are actually using. All right. What happens when your size equals capacity and you do a pushback? It'll change the size, right?
What is max size?
That's a good question. Let's see what that is. Actually, I've never used this function. Returns the maximum number of elements that vector can hold. Okay, that sounds like capacity to me. Wow. I'm going to start making new tabs. Okay, so capacity, express it in terms of elements, and it's a const, and max size is maximum elements that it can hold. Really looks like the same function to me.
Yeah.
That happens a lot. All right.
Which one am I gonna be like typing up later?
No, we're not programming any of these. But I do want to go over a couple of important characteristics of vector while we still have these in our mind. So let's go over here. Let's say, we'll call this a vector. Am I on board? Good. Slash array. And where is the glare? Glare, oh great. Glare is right. All right, perfect. All right, so it's over here, so I'm going to put my title somewhere else. All right, we should start studying the big O of different operations. Okay?
Okay.
So in the back, thanks, nice. What's going to be the operation for push back? Big O of. Ooh, this is a bit of a trick question.
Are we asking what's the big O of?
Pushback. What's the big O of pushback? In? Is it always in?
No.
Is it, okay, when is it not in? Let's say that there is space at the end of the vector. What would this be?
X, where X is constant.
Right, so big O of 1. So I'm going to put average O of 1. What's the worst case? O of, I think I heard it. Hmm?
N.
In. Why is it O of N?
Because you can everything copy all the elements into a new array that's bigger.
Right, so if it ends up being that you can't just extend the array in memory, you have to create another chunk of memory and copy everything over. That's an O of n operation because you have to copy. Everyone see that? All right. Let's look at push front. What's that?
Is it always gonna be over?
Yeah, it'll always be O of n because you always have to shift the array down. If you have to make another size, that's O of n plus O of n, which is still O of n. So push front is always O of n. That make some sense? Yeah. All right. Let's see, what would be another good one here? All right. Get is going to become get the ith element. I have an array of 100 elements. Give me the value at position 55. O of 1. All right. And let's say we have push back, push front. We'll have delete back. Let me rephrase that to remove back. If we're going to remove the back, aka the last element of the vector, what's the big O of that? O of 1. Is it ever going to be O of n?
Yeah. Well, if you remove the first element. then-
Remove back, removing the last element, sorry.
Oh, back.
The last element.
Never mind.
It's O of 1 because you're just decreasing the size. You leave the capacity alone, you just decrease the size, you're good to go. It's O of 1. All right, there's the glare.
Glare's O of 1.
Nice! I like what you did there. Remove front. All right, you're going to move the first element of the array. What is that? Oh, is it ever O of 1? Well,
Yeah.
It's O of n.
O of n.
Oh, one of the one element.
Yeah, well, if n was 1, then this would be correct. Right? Good catch, though. Good catch. Good catch.
N represents the number of elements.
Yeah, n is equal to the number of elements in the array. All right. Everyone good with this? Keep that in the back of your mind. Sounds good. All right, any other questions about vector before we go on to our next data structure? No? Great.